Now we have another method, that is cross multiplication method. In cross multiplication, we have two standard quadratic equation, that is a1x plus b1y plus c1 will be equals to 0, a2x plus b2y plus c2 is equals to 0. Now the name implies that cross multiplication. So we have to do cross multiplication so that we can find the value of x and y. Now if we want to the value of x, now put this hidden, then we have b1c2 minus b2c1. Now if we want the value of y, so hide y, we get c2a1 minus a2c1. Now for constant, we have a1b2 minus a2b1. Now with this value, if we want to find the value of x, we can directly take x and constant term. By cross multiplication, we have b1c2 minus b2c1 upon a1b2 minus a2b1. Now to get the value of y, we have a1c2 minus a2c1 upon a1b2 minus a2b1. With this formula, we can use and find the value of x and y. You just have to compare your equations with this standard form and you can put these values directly in this. Okay? Now let us take example number 14. Now in example 14, from a bus stand in Bangalore, if we buy 2 tickets to Mangaleshwar and 3 tickets to Yeshwantapur, so 2x plus 3y, the cost will be rupees 46. If we buy 3 tickets to Mangaleshwar and 5 tickets to Yeshwantapur, we get rupees 74. Now we got two equations. Now put in our standard form. So we get 2x plus 3y minus 46 is equals to 0. 3x plus 5y minus 74 will be equals to 0. Now by cross multiplication, first we will compare these values. a1 will be 2, a2 will be 3, b1 will be 3, b2 will be 5, c1 will be minus 46 and c2 will be minus 74. Now x, y and 1. The formula of this, that is b1c2 minus b2c1, c1a2 minus c2a1, a1b2 minus a2b1. Comparing this value, we get x upon b1, that is 3, c2, that is minus 74, b2, that is 5, c1, that is minus 46. Y will be equals to c1, that is minus 46, a2 will be 3, c2 will be minus 74 and a1 will be 2. a1 x upon minus 222 plus minus and minus will become plus. This minus and this minus will become plus. Minus 46 into 3 will be minus 138. Now this minus and this minus, again this will become plus 148. Now by subtracting this we get x upon 8, y upon 10 and 1 upon 1. Now compare this. X upon 8 will be equals to 1 upon 1. This will be x is equals to 8. Now compare y upon 10 which is equals to 1 upon 1. This implies y will be equals to 10. So the value of x will be 8 and value of y will be 8. The fare from the bus stand in Bangalore to Mangaleshwar is rupees 8 and fare to Yashwantpur is rupees 10. Example 15. For which value of p does the pair of equation given below has unique solution? 4x plus py plus 8 is equals to 0. 2x plus 2. So we know that unique solution for which we have unique solution when the lines intersect each other, means a1 upon a2 is not equals to b1 upon b2. Now comparing, a1 will be equals to 4, a2 will be equals to 2, b1 equals to p, b2 will be equals to 2. Now putting these values in this condition, we get 4 upon 2 is not equals to p upon 2. Now this p will be not equals to 4. For all values of p except 4, the given pair of equation will have a unique solution. Only except 4 we have a unique solution. Now example number 16. For what values of k the following pair of linear equation will have infinitely many solution? Now infinitely many solution means these lines will be coincident. Now the equation given, that is kx plus 3y minus 3 minus k minus 3 will be equals to 0. 12x plus ky minus y is equals to 0. Now comparing a1 upon a2 will be equals to b1 upon b2 will be equals to c1 upon c2. a1 will be k, a2 will be 12, b1 will be 3, b2 will be k, c1 will be k minus 3, c2 will be minus k, and here also minus, so minus minus will cancel. Now with this value, first we will take these two. K is equals to 3. This implies k square is equals to 12 into 3. Now this implies k square will be 36 and k will be plus minus 6, because the square of 6 will be 36. Now putting this and this, 3 upon k will be equals to k minus 3 upon k. By cross multiplication we get 3k is equals to k square minus 3k. Now 3k will be this side, then k square is equals to 6k. Now 1k will be cancelled. We get k is equals to 6. So therefore the value of k that satisfies both the condition is k is equals to 6. For this value the pair of linear equation have infinitely many solutions. So in place of k, if you put 6, the condition will be coincident. Now 3.5, like this you have 3.5. Now please solve these questions. Equations reducible to a pair of linear equation in two variable. Now example number 17. 2 upon x plus 3 upon y will be equals to 13. 5 upon x minus 4 upon y will be equals to minus 2. Now in both the condition we have x and y in denominator. So we can take 1 upon x will be s and 1 upon y will be t. Now our equation will become 2s plus 3t equals to 13. 5s minus 4t will be equals to minus 2. Now these two equations we can find by substitution, by elimination or by cross multiplication. Now here we will find. Now we can solve this by substitution. So by second we have 5s is equals to minus 2 plus 4t. S will be equals to minus 2 plus 4t upon 5. Put this value in equation. This we get 2 into minus 2 plus 4t upon 5 plus 3t is equals to 13. 22 minus 4 plus 80 plus taking LCM, this will get 15t is equals to 13. 23t is equals to 13 into 5 minus, or this will become plus. T will be equals to 65 plus 4 upon 23. T will be equals to 69 upon 23. T will be 3 ja. The value of t will be equals to 3. Now put this value 3 in any or here we can put. S will be equals to minus 2 minus 4 into 3 upon 5. S will be equals to minus 2, 4, 3, 12 upon 5. S will be equals to 10 upon 5. S will be equals to 2. So the value of S will be 2 and T will be 3. So here we have taken 1 upon X, that is S. So 1 upon X will be equals to 2, means X will be equals to 1 upon 2. Y will be equals to 1 upon Y equals to T, that is 3, means 1 upon 3 will be equals to 1 upon Y will be equals to 3, then Y will be equals to 1 upon